Okay, so this is going to be our Chapter 4, Lesson 1. This is all about terminating and repeating decimals, and a lot of this lesson is going to be familiar to you. So some things we're going to go through kind of quickly, but please remember that you can always refer to your Chapter 0 notes or even the top of your Chapter 4 notes where we did the prerequisite knowledge. So these notes will be at the bottom of page 1 in your Chapter 4 notes. First is a definition for a terminating decimal. A terminating decimal is a decimal that ends. That's it. As long as it has an ending, as long as it doesn't go on and on and on forever, it's called a terminating decimal. So I have 4 examples for you. 5 and 5/10, 9 and 102 thousandths, and 8/10. Also, whole numbers are technically terminating decimals as well. So 3, the whole number 3, it would have a decimal after the 3 and it would end, so that is a terminator as well. Repeating decimals. Repeating decimals are decimals that continue on forever and they have a pattern to them. So if you take a look at my 3 examples here, my first example is 0.33333333. You see these 3 dots at the end? Those are called an ellipsis. That tells me that the number continues and goes on and on forever. And since it starts off in this pattern here, we can assume that the pattern itself keeps continuing forever as well. Same thing for my next example, 1.15151515, and that continues on forever. And my third example is 25.7888888. That continues on and on forever. So repeating decimals are decimals that have a pattern, and that pattern continues forever. Some old information here. If we want to change a fraction into a decimal, you'll see this in your example problems 1, 2, 3, and 4 in your notes. The first thing we want to do is we want to divide the numerator by the denominator. And so let's do a really fast example problem here. Let's say we start off with the fraction 3/4. So if we want to turn this into a decimal, we're going to drop the numerator into the house and we are going to divide the numerator by the denominator. So divide 3 by 4. Many of you already have this answer memorized. We use it a lot. You get 0.75 or 75 hundredths. One thing that I want you to know, this is our only new thing about changing a fraction into a decimal for this chapter, and it's that if we start off as a negative fraction, then we're going to also end up as a negative decimal. And I think that makes a lot of sense. These are 2 numbers that represent the same part. If it's negative as a fraction, it'll be negative as a decimal as well. If I were doing these problems in your practice problems of Chapter 4, Section 1, I would probably focus on changing the fraction to a decimal first, and then I would add in my negative sign at the very end. Next thing we want to talk about is how to change decimals to fractions. And this is the way we've done it for a long, long time. We do the 3 R's. We're going to read our decimal, we're going to write what we hear, and then we reduce or simplify. If you remember in class, we called this the 3 R's. I know that number 2 isn't technically an R, but it has that R sound. So read it, write it, reduce it. Those are my 3 steps. This works perfect for terminating decimals, but it does not work very well with repeaters. We're going to see that in just a minute. Let's take a look at an example. Let's say my example is 0.6. If we want to change that into a fraction, we have to first read it using place value, so that's 6/10. And then we write what we hear, 6/10. That tells me I've got a numerator of 6 and a denominator of 10. Final step in this problem is to reduce it or simplify it. And when we do that, we just divide out the common factor. So I know that I can divide 6 and 10 both by the number 2, and that gets me a final simplified fraction of 3/5. The only new note for this part is, again, if we have a negative decimal, then that is going to result in a negative fraction for our final answer. So be cautious of that. Again, if I were you, I would handle the conversion first and then just remember to bring over your sign in your final answer. Time for something new. So we are now changing a repeating decimal into a fraction. I think that we know that repeating decimals will become fractions somehow, but we probably don't know the trick to doing it. So here is the trick. First, we find the pattern. We identify what's actually repeating in the problem. So here's our first example. My problem is 0.33333 repeating. The pattern that's going on is that we are repeating this 3 over and over and over again. So step 1 to changing this into a fraction is identifying the pattern. That pattern is a 3, and that 3 becomes my numerator. Step 2 is that for every digit in that repeating pattern, we're going to put a 9 in the denominator. So we've got 1 3 that repeats over and over and over again. So we're going to put 1 9 in the denominator. Final step is to simplify. I know I can divide by 3 here in the numerator and the denominator, and that will give me a final answer of 1/3. Many of you already know that 1/3 does end up being a repeating decimal, and that repeating decimal is 0.3 repeating. So this is how to change back from a repeating decimal to a fraction. Let's try it on our next example, 0.787878 repeating. First thing we do is we find the repeating pattern. I notice that it's the 7 8 that's repeating this time. So 7 8 is my numerator. Then remember, for every digit in the repeating pattern, I'm going to write a 9. So there's 2 digits in the repeating pattern. I'm going to write 2 9s in my denominator. Then we simplify. Using rules of divisibility, I can tell that both of those numbers are divisible by 3 as well. So I'm going to divide a 3 out of my numerator and divide a 3 out of my denominator, and I get 26/33. You can check my math on that if you'd like, but what's really important is that you understand the method here, and the method is to pick out that repeating pattern, write that as your numerator, and then we're going to put a 9 in the denominator for every digit in the pattern. I'm going to warn you really fast, this only works for the type of repeating decimals where the repeating pattern begins immediately after the decimal. See how we start with our repeating pattern right here, and after the decimal we start with the repeating pattern immediately in that example too. I want to take you back really fast to our first page. If we look at our third example for our repeating decimals, if you notice in this problem, the repeating pattern does not start immediately after the decimal. First we have a 7 here. Our method for changing this into a fraction won't work. We have to do a different system, which I can show you in class tomorrow. It's a little more heavy on algebra, so I like to give you the 9 rule to do the shortcut for this type of problem. Either way, very, very good rule, easy to do, and I think you'll be great at it. Remember again, if these were negatives, if this was a negative decimal, that would be a negative fraction. So that will help you in your practice tonight. So here's your assignment. You need to complete your Chapter 4 Lesson 1 notes. This is all of page 1 in Chapter 4 note packet. I want to make sure you get those problems done, 1 through 8. Really focus on changing them back and forth. Pay attention to the negative signs. And I also want you to make sure you do number 9, write your own problem, and then don't forget to do your Google form. If you have any questions, ask me in class tomorrow. Make sure to make a note of it on your form, and we will talk about this further.